So here we'll look at an example where we have permutation, but there's a certain condition involved. So here we have the word family. I'm trying to figure out the number of 4-letter arrangements I can have, but the condition is it must start with an M. So I can apply the fundamental accounting principle here. So we draw 4 blanks to represent the 4 letters. Now if it must start with an M, there's only one choice for that. It has to be the M. Now for the second position, it could be any of the 5 letters remaining. Then there are 4 choices left for this one, and then 3 choices left for this one. And the fundamental accounting principle says I multiply all of them together to give me 60. Now I could have used the permutation formula as well. So the NPR formula, N representing the total number of objects and R is how many I'm choosing. So here the total number would actually be 5. And not 6 because the M has to be placed at first. So there's 5 letters and I'm only choosing 3 of them to arrange. So that would give you 60 as well if you use the formula. Now here we got 6 friends going to a movie, and we want to determine how many ways they can sit if Bob and Frank must sit together. So that's the condition we have in this example. So I'm going to think of Bob and Frank as being together in one group because they have to sit together. So I'm going to group them together. I also have Al and Carl and Dan and Ed. So we look at how many ways can I arrange 1, 2, 3, 4, 5 people. That's 5 factorial. Now if I look at Bob and Frank here, they can be arranged themselves in 2 factorial ways. So if I dig out my calculator now, 5 factorial is 120, 2 factorial is 2, for a total of 240. Now here in the next example, the condition is that Al, Bob, and Carl are not going to sit together. So the best way to approach this question right here is to find the total number of ways that they can be arranged. I'm going to subtract the case where they actually are sitting together. I'm going to subtract the number of ways where they are together. And this is going to leave me with all of the cases where they are not. So what's the total number of ways that those 6 friends can be arranged? That's 6 factorial. Now, what's the number of ways that Al, Bob, and Al actually are sitting together? Well, I'm going to do that just like I did up here in A. So I'm going to group Al, Bob, and Carl together. I also have Dan, Ed, and Frank. So I'm going to ask myself, how many ways can I arrange 1, 2, 3, 4 people? That's 4 factorial. Now Al, Bob, and Carol, they can be arranged themselves in 3 factorial ways. So 4 factorial is 24, 3 factorial is 6, for a total of 144 ways. So going back down here to my formula, 6 factorial minus the number of ways they actually are together, 3 factorial, 4 factorial, that is 720 minus 144, for a total of 576 ways.